Remember, your first restriction for your fractions is you can't have 0 in the denominator. So I'm going to abbreviate. Remember, the denominator cannot equal 0. And then your square roots, remember a root has to be greater than or it can equal 0. There is one more, guys, that I want to talk to you about, and that is going to be a combo of both of these. What if I have a root in the denominator? What's going to be the restriction on that domain? Anyone want to take a guess? Perfect. Great job. So we're just going to say the domain for this is going to be just greater than 0. Good. That's right. So that's a combo of both of those. Okay, so now that we've kind of reviewed about our restrictions, guys, we're going to find the domain for both of these algebraically. So for this first one over here, let me straighten my work. For this one right here, we have a fraction. Remember, you can't have 0 in the denominator. So let's look at the denominator. The denominator is x squared minus 7x, and remember that cannot equal 0. So I'm just going to solve this inequality right here. And then we're going to do a lot of solving today. I just want to point out something to you. When I wrote this with my purple pen, how many times did I write the letter x? Did I write the letter x just once or more than once? Good. If you ever are solving and you have that variable written more than once, your only way to do this is to factor. So we're going to factor and solve this inequality. So let's go ahead and factor. The only thing they have in common is an x. All right, so we know x cannot equal 0. What about in these parentheses? What can x not equal? What would make that a 0 in there? Positive 7, great. Remember, your answers for these x values are always the opposite of what's in the parentheses. Good. Now, those are absolutely the answers. That is what x cannot equal. However, you guys, on tests and quizzes, especially free response, I'm going to ask you to always write it in interval notation. So let's talk about how this is going to look in interval notation. We're going to go ahead and you have to write it in order from least to greatest. We're going to start with negative infinity. And negative infinity is going to take us all the way up to our lowest exclusion. Which one of these is lower, 0 or 7? Of course, 0. So negative infinity to 0, and then you always pick up right where you left off. We left off at 0. 0 all the way up to our next exclusion, which is 7. All the way up from 7 to infinity. So someone asked earlier, when do I use the AND statement? I will tell you when we use the AND statement. 99.9% of the time, especially if it's an equation. If you see an equal sign, you're always going to use the letter D. I'll talk about AND in a moment. Okay, guys, how many restrictions did we have? How many answers could the denominator not have for x? 0 and what else? How many was that? Yeah. Whatever number you have, you're always going to have plus one more in your answer. See, that's a piece. That's a piece. And then this is a third piece. It's always going to be one more then. All right, let's talk about the domain for number 2. It's going to be a little bit easier. Well, I think it's going to be a little bit easier. All right, let's take a look at number 2. So it is a square root. So remember, we need this to be greater than or equal to 0. We're going to solve this algebraically. And guys, there's going to be a lot of stuff where I am going to ask you to not show work on. For example, y'all, if something is being square rooted, how do you get rid of the square root algebraically? What do you do to both sides? Good, you square it. Don't show that part. Just when you square both sides, think about what it's going to look like. That square root symbol is going to go away. 0 squared stays 0. We're just going to move the 5 over. If it's negative on one side, then it's positive on the other side of the equal sign. And that's it. But again, we have to write it in interval notation. So to write this in interval notation, we are going to have a bracket for 5. And remember, it goes up to infinity. And that's going to be the answer. Remember, it only has one exclusion, so it's only going to have one piece. All right, let's go ahead and take a look at these graphs. Now, for these graphs, guys, usually they're a little bit easier, but I'm going to try to throw you curveballs and tricks. I'm going to try to trick you. Do not fall for my tricks. So for this first one right here, please remember when you are looking for domain, you always work from left to right. I'm going to start looking on the left side and then go towards the right side of the picture. So when I scan, the first thing I see on the left is this dot right here, and it's closed in. So I'm going to start with whatever that number is. What is that? Y'all, I can't read that. It's too little. Is it 7? Negative 7? Sounds good to me. Now, since this graph is so tiny and my eyes are so old, I would just glance at that and I would write positive infinity and move on. But you guys are much younger and you should be scanning from left to right. Look right here. I could have overlooked that if I didn't take my time and really analyze it. What is that on the x-axis, guys? Thank you. So let's block out negative 2. Let's pick it up right where we left off there because that graph keeps going. And there's no more holes there. So we can go ahead and wrap this up with positive infinity. Now, for the range, remember the range is from the bottom up. So we start at the bottom and we work to the top. All right, so for the range, when I scan at the bottom, the first thing I see is this. Is that negative 5 down there? Okay, thank you. So, guys, if it doesn't have a big open circle like it did up here, you are going to include it. So that negative 5 is actually going to have a bracket. And then, guys, look. See this arrow? That arrow is eventually going to fill this dot over here on this side. So it's just negative 5 to infinity. The graph is going to go up forever. Do you have any questions on that? Let's try this one. So for number 4, guys, if you see number 4, there are not any arrows at all. If there's not any arrows at all, you're not going to have any infinity in your answer. So look, the domain starts here. It's a closed-in dot. I know it's a bracket, but remember, I have old eyes and I can't see. Is that a negative 2? I'm asking, is that a negative? Thank you. All right, and we're going to go all the way to whatever number that is. I know it's a parenthesis. What is it, guys? 6. Thank you. And then let's talk about the range. So the range is going to be from the bottom up. All right, now the first thing I see, I notice that it's sitting on the x-axis. I see a closed dot and I see an open dot. If it's a closed dot anywhere that you see, it's going to be a bracket. So that's going to be 0 to the top. And I believe that's a 4. I don't know, is it? Thank you. And it's filled in. So that is what that graph is going to look like. I'm sorry, that's going to be the domain. By the way, y'all, those are and statements. I need range, I need domain. I need inputs between negative 2 and 6 has to have both of those parameters. My range, my output has to be between 0 and 4. So So those are the types of and statements that you're going to see when it comes to domain and range.